Hmm. Hmm. That's why I did get the 0. And ignored the escape stuff here. Okay, then we do the following. I just want to get rid of that. If there is a declaration, then I guess it's okay. Alright then. God. It's hard to make chocolate milk with the anti-noise headphone on. I don't hear what I'm doing. There. Yeah, it's finished. Long ago, probably. Okay. To the maximum unique lines, and well, this minus u here means unique, is 5,500 and something. I've got what? 70? Yeah, we're not going to see that anymore. No, let's try to scroll up anyway. Nope. It's done. Let's just count it. $5,509. It's pretty perfect, I think. I'm going to calculate it again. Times 4 times. Let's do it differently. 9 times 4 plus 8 times 4 times 3 divided by 2, I think. So 6 plus 7 times, and that is then 4 plus 6 times 1. So whatever. Blim, boing, ding, kading. Yeah, so we have all of them. Cool. Pretty cool. ISO is I could plug the music that I'm listening to through. I hate YouTube. Is that not a streaming something where you can just play whatever music you want? Hey, Dan, my man. Vulkan engine does. Yeah, well, that's kind of difficult. It's not finished yet. It's just, you know, currently, no, it's too difficult. Sorry, I cannot show it. I could maybe give an explanation if you knew Vulkan, but I doubt you do that. No, okay, because it's you. Let me try. New tab. Wait a minute. New tab, YouTube. Linux viewer. You can go to source tests. So suppose you want to make a this is the most complicated test application that I have at the moment. It recompiles everything because I upgraded my libraries. Well, not my libraries, but the operating system. So this is an application, and you can see here we have a little window which you can't move. Can also not move. I can, however, change the swap chain image count and the number of frame resources, and I can change the amount of work on the CPU that it does. And the scene complexity. So reduce scene complexity is a few squares. Each of these squares is a major amount of like 1,000,000 triangles or so. So if I put 1,000 on them, the frames per second already dropped to 10. It's just drawing a lot of triangles. Well, even now 30 frames per second, because if I put like this, I limited it at 60 frames per second, so it's never gonna go higher. But even with a few of these, see how many I can draw here. This already drops below 60, just 210. Now, if you want to write this in Vulkan, I cannot tell you how, because Vulkan is extremely difficult. It would take a month to explain. I mean, look at the vulcantutorial.com. It's like a major long, many YouTubes for a tutorial to draw a single triangle. And my engine should make that simpler, in that this whole application is made with just these files. So just a few files, not much. And the files themselves, they are in the kilobyte range, with the exception of window. That's the biggest one. Let's have a look at this one, which is also pretty big, heavy rectangle. So this is one of those squares that you see being defined here. We call it a heavy rectangle because it's heavy on the GPU. And then, yeah, it's mathematics, so I give it specifications. And you know, each of these squares here are actually two triangles. And define here what is what, you know. And then you have to turn that into code. And that's all. I mean, this is like the biggest header file that I have, apart from the window.h. It's just very specific, and putting in code how to build one such rectangle. And then the window.h file. Well, no, maybe I should also show you all of them. This is the application. You can define or override a virtual function to define the number of worker threads in the thread pool. And we have an application name, also a virtual function. We just looked at that one. This is instance data. This is basically this struct here. And it exists of two arrays. One array is not used and the other array is also not really used. Just one element of them is used. I made it more complex than necessary, just to showcase, as it were. Well, it's a test application, right? So this is a struct that is being sent from the CPU to the GPU, and well, an array of these things. So I have a buffer, which is actually an array of many of these structs, and I fill them on the CPU, and then I send them to the GPU. And in order for my Vulkan engine to support that in an easy way, you have to tell the engine everything about the struct, and you do that by this block. So this is a macro. You just have to type this, and then the name of the struct, which must be for declared here. And you can choose if it is per instance data or per vertex data. You have to pass that as well. This is again a magic incantation line. And then you have to use the macro layout for each of the members, passing the type and the name. So compare this, or maybe just this, because the rest is just always the same, with the actual struct. And you can see that I have two lines here because I have two members, okay? And the name here repeats there, this name repeats there, this type repeats there, the size of the array repeats there. So this is defining my instance data. Maybe it looks complex, but hey, it's like 20 lines or so. It's absolutely nothing, and it's every time the same. I have another one. That's the instance data. Let me go here. There's another one, push constant. So here I have a struct push constant that exists of 5 floats. I just define here the layout of that. It's a one-on-one translation. ChatGPT could do it. And then we have logical device here. It's derived from the logical device defined in my engine, Vulkan engine. Also, the namespace Vulkan contains Vulkan engine stuff. And then I define a few things here that have to do with the window. Let me see what we have. Features we need. So I set the depth clamp to true here. Most of these things are just, you know, virtual functions that are being filled in. So this override means that you override a virtual function of the base class. And then that's the way to give information to the Vulkan engine. Here's another one that's overridden. This is that's all in this header. This is a very complex example, but that's because I just test everything. What I do here is I define the number of queues that I want to have. The GPU has queues to send stuff to. And here I'm saying I want to have a graphics queue. I need a most 13, and they're pretty important to have. So, you know, if there is not enough queues, then it's going to give more priority to the graphics queues than to, for example, this one. This is called, this word here is not Vulkan, yeah? This is my Vulkan engine stuff, so I invented that to do it like that. So he said, I want to have a queue, which is a graphics queue, and I want to have a queue that is a presentation queue, but if possible, you must combine it with the graphics queue. Now, it depends on the GPU if it's possible or not. So in my case, I have an RTX 2080 Super, which has queues that can do both graphics and presentation. So it combines that. And then I get probably 13, just 13 queues. So I have 8 presentation queues as well then. But if they would be separated, so they would not be combined, and then this priority is being used. Yeah, it's like it says here. Also the maximum number of queues, you know. So if they're combined, it's just using this. And it is combined in my case. And here this comment also says, by passing this as a cookie, you say that this queue may only be used for window 1. So here I have another cookie, and well, that means that this transfer buffer may only, and a maximum need to, may only be used for transfer. I mean, it's not difficult, and if you compare it, let's say, with the actual Vulkan API, it's super easy, because this is just a non-duplicated, one-time statistical data, almost statistical because of the priority. You hand wave what you think that you need, and then the Vulkan engine figures out how to exactly do it for any GPU. And normally you would just have something extremely simple here. This is, yeah, I think using everything that is possible at the moment. Okay, so this is a header that describes the randomness of how the windows were placed. Yeah. So I run the if I run the test application, Now you see that the windows are placed randomly. Yeah, that randomness has to be defined as well, and that is defined in I'm going to go through all the headers again. And now what the hell I do next? Now we go backwards. Okay, but I was here actually. Random positions. Now that's the whole file, so it's really small. And it uses an interface that I made up using virtual functions again. So you define what the chunk count is and the create entry is. I guess it needs documentation. Yeah, I mean that's what defines my my random placement. This is old code. I didn't really work on it because the application was originally a tutorial from Intel. I completely rewrote it, but I still kept certain things, and this is one of those structs that came from the original code. Okay, vertex data, another struct that I need, which is being defined here. And then we have the window.h. Now this is the largest file, and probably then the most close to the actual Vulkan API, and therefore the hardest to understand. So you have to define a window for each window that you have, which must be derived from that base class. And that is a task. So it requires me to define might require me to ask to define certain condition types that I'm going to use. I have a render pass must be defined. Well, this is a super simple one, so just render pass is the only pass that we have, main pass. Okay, I have a depth attachment which is defined here. I have a vertex and a fragment shader. I have 2 combined image samplers in total in there. We have names for that. Background and benchmark are they called. We have vertex buffers, of course. Here are those 2 things. The heavy rectangle and the random positions that I showed. Now, all those things that you need to build application are defined in this class. We have push constant range. We have textures. We have, of course, a pipeline. We're going to have a pipeline. The stats window comes, finished. So you just add a stats window here, and then you can see the frames per second. Then we have the virtual function overriding again. So every time you see the override, it's just an initialization of the Vulkan engine by means of implementing some, of overriding some virtual function of the base class. So this one sets or allows you to set the default clear value. It's commented out, so it doesn't do anything here. This one must be defined to create a render graph. And trust me, this is as extremely few things, I mean, if you do this with the Vulkan API, it costs you 2,000 lines or so, and here I just it's like 3 lines. 1 line, 2 lines, 3 lines. So this says we write to the presentation attachment of the swap chain. And then my render graph is defined as the main path, which takes a cleared depth and stores in the output. And if IMG is enabled, then we also have after that an IMG pass which stores to the output. I invented this. I mean, this abuse of C++ syntax, of course. And each of these little things mean something else than that you otherwise would think that it means. So, again, documentation required, but it is short and powerful, right? You can just make a random graph, a complex random graph with, just a few lines, or depending on how complex it is. This is kind of the most simple random graph that you can make, I guess. And then you have to finish with this line all at the end always to actually make the render graph. Now I have an override here for the maximum number of frame resources that we have, the maximum number of swap chain images that we have. We have a function, also an override, that prepares the textures if you want that to prepare it immediately. So that's loading it from disk and then uploading it to the GPU. I mean, look at the Vulkan tutorial, what you need to do in order to get that. And I do that in half a page. There's another one. Now this is one line for a complete vertex buffer. So we have the per vertex and per instance vertex buffers, which are here created and everything. Well, maybe not. It's probably just registration with the Vulkan engine, and it happens later at the right moment. But yeah, it defines the stuff. Now, then I have here shader code for vertex shader, and shader code for the fragment shader. And also pretty important is that you can just use this. Strings that normally are not part of GLSL. But my Vulkan engine is going to recognize these things, because you told that they exist with the code that I just showed. And then it figures out what the declaration needs to be. So it's going to generate declaration and put that in front of this and then compile it. That involves also generating, deciding in which descriptor set to put it, generating the descriptor set numbers, generating the binding numbers, and keeping them all consistent over multiple invocations. So if you use the Vulkan API directly, you have to make sure that you do not mess it up. Everything must in a certain order, and the order vector, you pass vectors to structs, the point at which you pass to another struct, the point at which you pass to another struct, which is used to create something, which you pass a vector, which has other module handles that you created before, and then the order in which things in vectors are used correspond to indexes that you had to use somewhere else. And well, one big error-prone approach. Very flexible, but I couldn't get it to work. It's not easy to get it to work, and it's very easy to make mistakes. It's just a horror. My engine makes sure that you don't have to do that at all. You just say, I want a background texture. And then it figures out all those numbers and the orders and the vectors and the consistency and everything. So here I'm registering with the Vulkan engine, and again an override. They share the templates. I call them templates because they have to be preprocessed, because of these strings. So yeah, I mean, these are just inline or raw strings. And then I put them here into a vector of shader info. This is a debug name, I think. This is which stage it is. So we have a vertex and a fragment stage here. And as you can see, this is at index 0, this is at index 1. So then we call on that load with the template code. And then we call register shaders on the application. And then I can read back from whatever is returned handles, which then must be stored in vertex shader index and the fragment shader index, so I can refer to it later on. Now we'll run into it, I guess. Now, in order to build a pipeline, I invented that you have to make pipeline characteristic, define pipeline characteristics. Multiple of them. And let's not go into detail, but this is just doing viewport and scissor stuff. And initialization, okay, what do we have here? Color blending and the dynamic states. And we define the assembly state create info topology, which is a triangle list in this case. I mean, you have to supply the information once at least. I just try very, very, very hard and succeed, because it's unacceptable not to succeed there, that you have to only supply everything exactly once. So you will see here triangle is, you will not see it anywhere else. This is the place to define what the topology is. It's not going to be done anywhere else. And that, I think, makes code also much, much better. Now we have another pipeline characteristic. This one exists of the vertex shader, fragment shader, and push constants. That's what my pipeline is going to exist of. And then in initialization, you define the push constants, and you tell it what the vertex buffers are, and here's my handle, the two vertex buffers that we registered before, they are being added here. They have an override for the graphics pipeline itself. You're going to say, wow, man, this is still incredibly difficult, and it is. But it's also, I think, a lot less code than you need when you do it directly in the Vulkan API. And eventually, it is therefore simpler. You can make less mistakes, I think, because you just specify something that you want, you specify it once. And not you don't have to take into account that if you specify something here, then you also have to, get it right at a different place. Okay, this is an important function, of course, that renders one frame. More or less always the same code, I have to say. You call it start frame, acquire image. This is then code that is application specific. Then you call the draw frame function. Again, application specific, finish frame. Application specific, we just time how long it takes here. The draw frame is also defined by the user, so that's this function. Here we make use of this the render pass or the render graph object. And then you have to build a command buffer to send that to a queue. I didn't do very much work on this yet, so it's still pretty verbose. Probably almost as verbose as Vulkan itself, with some debugging stuff. So it's a lot more verbose actually. All those Tracy stuff is debug stuff. Now we have an override for the IMGU. So IMGU is a user interface, but should only be used for debugging. And in this case, you know, this is all there is that you have to define in order to get those sliders and stuff. And that's all. Now I bet Dan left in the meantime. You're still there, Dan? You ask me, can you show me the Vulkan engine? Well, that's what I have to show. An example of how it looks when you use it. I think he actually left. Now back to my test. I'm going to remove this, I think. Big, huge files do not belong in videos. And then pipeline layout, yeah. What I'm currently doing is main.cpp. We just show declarations. Okay, I think I might as well go back now to a single pipeline. Hopefully. The full thing. Run it. So pipeline exists currently of a single stage or not? It looks like multiple stages. Oh, already have 3 stages. Yeah, we have 3 stages already here. And then each stage, of course, has a shader module related to it, which then has between 0 and 4 declarations. And the declarations we already tested. That works now. Now, looks like the stages also work, right? Just always 3 stages. So we could generate brute force everything here. Note that the layout is empty. That fixed me. So if I have 3 stages and each stage generates 5,509 possibilities, then the total number of possibilities is that to the power 3 now. Now before I had, I think, 1.7 million possibilities, so there was a pretty big reduction already. I think that 5,509 to the power 3. Am I actually going to use this? No. You have a power here, yeah, to the power 3. Awesome. Enter. No, nothing works. Oh, equals, of course. Yeah. Okay, reset. Maybe that's reset, or clears reset. 5509. Oh, to the power 3. Well, that is a pretty big number. Pretty big number. We could wait for it if we do 1 per nanosecond, but I doubt that. So it's more for something for overnight and pretty useless, I guess, to do. Well, we can let it run anyway for a while, for a bit, just to look at the output. So this is the brute force one. Like this, it prints everything. And then it ends with the count. And wait, while I'm at it, that I don't think that that big number fits in even 64 bits, does it? I don't know. GDP. Ugh. 64 bits. It's this is 16, right? 4 times 4. 32. I think what is Carlos slow, but my music had a countdown for a launching rocket. Yes, vocals. And the guy was counting. Seriously. Oh, that's considerably larger than I thought. That's easily. No. It was just bigger than of course, it is bigger than 32 bits. That's what I meant. Also not? 1, 2, 3. Yeah, this is 4 billion. And we had 100 and something billion. No, that's all nice and dandy. But I so hate that. Vocals and music cannot work then. So after running a bit, we see that this one probably already did 5,509, so that this one was already incremented. I'm going to switch my music. And this one still didn't. So after 25, more, 30 million or something, this one should change as well. And now we have to do that 5,509 times. Gonna take forever. But what we can do is count, not print anything, and then say if count mod 5509 times 5509 equals 0, write the count. Well, divided by that. It's not too bad. I don't know, 10 seconds or something. To if it's 10 seconds. It's just 1,000 minutes before this finish. I mean, this has to run up till 5,509 now, and then it stops. Not gonna wait for that. Would be interesting, however, to see if we can make it faster by compiling with optimization. It should definitely make a difference. That doesn't look like any optimization is there. Debug. What? We cannot compile with without debug code. I guess this, maybe I should never include this, or is it just pure debug? Usage CWD as usage detector. Why is it even compiled then? Confusing. Stuff has been broken. Yeah, I don't think I put if dev CW debugger around any print on, so this is gonna take a while for every class. Make the VI the next one. That's another one. Implicit instantiation of undefined template standard tuple. In initiation of template, generate tuple, blah blah blah, requested here. Template is declared here. No member named for this tuple. In namespace SCD. That's also an interesting one. Tuple, I guess. Yeah. Header tuple. What? It's another one. Same error, but another file. Unbelievable. You think I can do this faster? You're probably right. Probably all of them, right? Let's automate it, as in QQ O if def CW debug escape 0 JJ percentage, I guess, O and if escape Q, yeah, and then next search, and now play back a macro. Oh my god, how do you play back a macro? Add Q, yeah. Next slash, I could have done the slash as well. Next, maybe I should redo the macro. Let me do QQ slash O if def CW debug escape down percentage O and if escape call next return Q. Is that working? Let's hope so, because we cannot even verify it anymore now. Cannot go beyond last file. I now can verify them one by one by doing this. So that looks all good. Yeah, all good, all good. Now, yeah, if one is good, then they're all good. So next is then the headers, which would be a void print on all headers. Yeah. Well, let's say we are here. I'm gonna record again. QQ / void print on. Return O if def cw debug escape. And then I guess just one down and an O. And if escape next Q. And then press add Q and pray. Oh, that one is already set. Next. Also. Yeah, I'm not doing this right. Or yeah, maybe I can. Maybe it's better to do this. I don't know. I still have to find these things on by hand, I'm afraid. See, and this is also not good. Definitely not good. No, that doesn't work. Let's quit. Thought there were only a few. Should have made a new macro. Thank God. Get tuple, I guess, also, right? Let's just gamble tuple. Hey, we're done. Yeah, that was with optimization. So how fast is it now? Oh, disappointment. Don't tell me it's... What? Oh, I don't have debug output anymore. Yeah. Oopsie. Let's just do standard C out. Count as that. There, that's like 10 times faster. Yeah, no, 100 times as long as that. So a little over an hour or so. Pretty impressive, actually. The speed. Now, to use all 32 threads. Then it would be 32 is fast, and then I can just let it run for 2 minutes. That would be cool. Can I quickly make this, turn this into concurrent code? Yeah, probably, but let's not do that. We already know how it works. Right, so let's go back to the random thing and then enable the layouts. And then we don't have debug output. I can do without debug output at the moment, at least, but not here. It's just oh wait, even that doesn't work, right? That is not working anymore because I just commented everything out. Yeah, now I need debug output, definitely. Okay, so the count we can do like that, but this is debug output. And so is this. How to do that? How to do that? Let me think. I want debug on, I want libcwd on, but and optimization as well. So that would be, I think, rel with debug is just debug info, right? It's just release with debug info. That's not what I want. Debug is not optimized, so maybe it's beta test. It's the only thing in this list, at least, that could be it. Try beta test. That's not helping. I guess I can search on beta test. Just minus I. Here it is. There it is. So no. Beta test is the same as release, but then with a search turned on. That's not possible. So not possible to get my debug output with optimization. I think the rel with debug is still something else. The other ones were deb info. But yeah, it just defines debug. Let's try rel with debug and then manually turn on libcwd, see if that works. Oh, it's turned on. It is turned on. I'm not convinced that it is using optimization for some reason. Nah, it should do. The Rails release, it is with optimization. Yeah, I think this is what we want. Well, all my layouts are still empty. Guess that's what I have to work on next then. Can I somehow see that this is wrong? Like pipeline layout, having an empty pipeline layout while we have while doing all kinds of stuff, that cannot be right. So it says wrong, this, correct? I should make an assert, as it were, like, hey, help, the pipeline layout doesn't match the rest. Now, currently, it's just generating random pipeline layouts without looking at all at this, but it's always empty. pipeline layout dot h. Pipeline layout is a vector of descriptor set layouts. I bet this vector is just empty and that's it. But no, I don't even have a randomize here. Why do I not have a randomize? Generated has a randomize. That is called randomize on all the elements of the container or on all elements of the struct, all members of the struct, which is, in this case, it's a vector. So we should call randomize on all descriptor set layout. Yeah, okay, that's the reason then. We don't have any, it's empty. So I need to add a randomize function here that increases the vector size. It's pretty standard by now, I think. Randomize. Not that standard apparently. Not standard at all. Let's try that again. I think this is the one. What this is doing, let me just copying it. I mean, I need something that increases the size, so we have a new sizes in it. Here is one of them, and that one is based on generate. And the one that we have here as well. I have another randomize that sets a new size. Not this one, not this one, not this one. Not this one. Not this one. Not this one. Come on, I have another one. No? Okay, then not. Ridiculous. No, this one. Let's just copy it and then look at it. Yeah, allow all is, I think, specific for something else. Allow all is defined, set index binding slots. Yeah, no. Shader module. Shader resource. Nothing to do with any of that, right? Plus my owner is, I don't have an owner. I don't have an owner. Well, not yet anyway. Well, we're going to have an owner. I bet we are going to have an owner. No owner. Hmm. I guess we need this here, number of shader resources. Hmm. I'm just going to define the uniform in distribution right here, because it's going to have to change anyway afterwards. I think it's gonna just like the other one, which I can't find anymore for some reason. So I have a uniform int distribution. Of well, size type parenting. How is this generate made? It's a template, okay. And then we want to change that vector here. That's this thing. New whatever. Descriptor set layouts. We don't have an owner. And then we add to that vector something, it plays back something. And then we move that and we don't have this. New descriptor set layouts. Move there. Yep, and then this creates a new size number of descriptor set layouts, which have those default constructors. Only default constructors? You gotta be kidding me. No, okay, so plays back is empty. For now. No, it's impossible. I need to pass a random number generator, don't I? I don't think this randomizes anything, but at least the number of the script set layouts should be varying now. Oh no, it compiles. It compiles. Okay, let's see what the output is. The layout now contains one. Just, sorry, why is there no column there? Is that a vector? No, what? Okay, so layout is a pipeline layout that contains a descriptor set layouts vector, which contains descriptor set layouts, which are objects containing a descriptor set layout bindings thing, which is empty. And then another one, which is also empty, another one, which is also empty. So just the number of descriptor set layouts in the vector now vary. You have a bunch here, and here we have less, and here we have just one. We're going to have 0 as well here. Looks like this one is 0. Okay, but yeah. Totally missing the content of the descriptor set layout itself. Why wouldn't I be able to call generated randomize RN? Shouldn't that work? Well, that would just call randomize on each of the elements. So let's see. Good. We create 3. I have a default constructor. Can I really just resize this thing? Not sure why not. I think I could do that. I think I can do that. Let's just do a resize. New size. Though, no, then it might, yeah, well, yeah, no, it's not default, not all default constructed then. But randomize should still randomize it. I don't think randomize expects per se a default constructed object. Or does it? Let me just look at it. Doesn't have. It doesn't have a randomize. Wait. Again and again a vector. Script set layout binding. Yeah, okay. That's horrible. Oh my god. Yeah, still does the same thing. Oops. Now I have a layout, pipeline layout, a scripted set layout. I need some formatting as well, clearly. This is become instantly unreadable. Let's put layout at the same level as stage. That's 4 spaces indentation. And then every descriptor set layout on a new line, kind of like green begins on a new line, right? Or not. I only have one descriptor set layout. Okay, let me check now. Pipeline layout exists of a vector descriptor set layout. So if the size of this thing ever becomes slightly larger than 1, and being ironic here, sarcastic even, why am I not seeing that? Oh, here there are 2. 3 even. Okay, so they do need it on a new line. Yeah, this is a better example. So this layout here has 3 of these, 1, 2, 3. And then that also contains a vector, which then contains bindings, right? So each of these contains also a vector with bindings. Yeah, so the binding of everything that is in a vector just should start with a new line, I guess. So GPS, the binding thing with the colors. Now we put quotes here with and then 12 spaces. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Make. Oh, it's better readable. It still wraps though, which is not nice. But yeah, we have a binding, and then we have a descriptor type, and it repeats the same word every time. Ridiculous. I could change how I write that, I guess. Just print the green stuff. And then it becomes a lot shorter as well. Yeah, no, it fits on one line. So we can have multiple descriptor set layouts. And then, see, anything with a B, can I do that? Yeah. Okay, so this means that we have a pipeline layout that exists of 3 descriptor set layout objects, whatever that may be. First one is empty, the second one is 3 descriptor set layout binding objects, and the last one as well. The binding can be 0, 1 or 2. Descriptor type can be 0 or 1. Descriptor count can be -1, 1 or 7. And the shader stage flags is a bit set of 3 flags because we have 3 stages. as a one set in whatever stage is using it. Totally random in this case, totally random. Yeah, now I have to make this consistent with this. If I ignore the shadow stage flags, then it says we are using three descriptor set layouts. What the hell is an empty descriptor set layout? Is it even allowed? Descriptor set layout. Okay. Let's find another one that is not empty. So the third one is always empty. Is the second one empty? How large is that change? I want to have three, and all three. Here there are three where none of them is empty. Is anyone stopping me from defining a layout where I have a binding on 0 and a binding on 2 and not a binding on 1? I don't think anyone is stopping me. The order of this vector is not important, so it should be sorted or sorted. It should be sorted. Actually, I do see something. You cannot have this same binding within the same descriptor set. So this would work. 0 and 2 are different, and 2 and 0 are different. And then we have the type, which it means the combined image sampler or uniform buffer. And both can be an array. So these two are uncorrelated. Whatever this is, that can be whatever it wants. This means that it is unbound, an unbound array. This is not an array, and this is an array, size 7, but well, some array. So the first optimization that I can think of is to also have them sorted, because the order is not important, and then I don't want to get duplicates because of the difference in ordering. Well, the ordering is irrelevant. Or am I shooting myself in the foot then? Mm. Well, I just have to keep it in the back of my head that although I'm only displaying 0, 2 and not 2, 0, that it can still be either. Am I currently generating the same binding number within a single descriptor set layout? Yep, I do. Yeah, 2 and 2. So here we are binding within this. Sorry, is that true? Yeah, within one descriptor set layout. I'm binding at the place number 2 two different types. It's nonsensical. That is totally nonsensical. So if these must be different and I order them, then these two can be whatever they want. Just totally random. That's okay. And then these, I'll leave them random for now, but in the end they must match whatever is up here. Somehow. I'm not sure how though. Like in this case, I have 3 stages. And the last stage is using no declarations whatsoever. Which means that it's not using any shader resource at all, which means that, well, this bit must be 0. It is, yeah, but that's coincidence. I have sometimes a bit that is it. Do I have 3 ones as well? Yep, 3 ones here. Do I have 3 zeros? I don't think I should have 3 zeros. Right. I'm going to concentrate on binding, but probably not today because I feel a headache coming up here. It's kind of early to stop streaming already, but yeah. Let's do something else. Seriously. Now, what happens if I take the knight? If he takes the pawn, I can give check, and the king can't castle. That seems pretty good for me. So he's got to take back with the queen, threatening to take here. But then I'm going to give check on my queen. And if he does not want to move his king, he could put a pawn in between, but I just take it. Exchanging queens and winning a pawn and killing the castle. Or I could put a queen in between and then put my bishop here and win a queen. Either way, he cannot castle anymore. He cannot castle anymore, or worse. Now he's thinking, he should have done that the previous move. Or the move before that. Moving this pawn weakened this square like horrible, and it's always nice to give checks over weakened squares. So you have the whole diagonal with weak squares, weak being like only defended ones or something like that. So no more castle for my friend, and then I'll just continue developing, I suppose. Defending this pawn at the same time. Yeah, if I move my bishop, then my knight is pinned, so he can take here or check. And that's pretty devastating. So he kind of cannot move my bishop. What about I just propose to exchange queens? This is probably a good square then. You could take it, I take back, and then he wins this pawn. Also not very nice. So what about moving this pawn up? I think that works. Leave me alone. All I want is to castle. Why is this guy so annoying? I'm not even up material. I just stopped him from castling. So yeah, if I then cannot castle myself, he's going to go there and then attack my bishop twice. I could defend it with my queen. Maybe. Queen here. Might work. I'm just gonna castle. I mean, I'll see afterwards, because castling has to be done. I'll just have to castle. There is no other way. So predictable. Okay, so now I can defend my bishop, I guess, with my queen. If now I go here, what's he gonna do? Move the queen? or take it. If he takes, I take back. Oh, I'll lose my knight. That's not good. So I have to defend it without putting my queen on price. That would be the only here then, the only possibility. I think I want to put my knight there. This blocks the queen from this annoying attack on c3. And then my bishop is not pinned anymore, and I can put a rook behind it to defend it. So all I want is one move respite, yeah, and then in English. Mosen, hello. He is doing something with the rook, not sure what. So now I can move my knight to where I wanted, right? That was a very good move. He's going to attack my queen. And then what? Then I have to go away with the queen. After I move my knight, I cannot no longer go here. I could do it immediately. He takes, I take, I'll lose this. Yeah, not good. He goes there, I can go there. Maybe I should start with putting my rook here. I don't have time anymore. Now I had to move a bit too fast. Definitely. If he goes here and I still want to defend my bishop, I have to go there. I can just take it, take, but now my rook is behind it. So now I can, now I can offer my exchange the queens, not under the defense of my bishop, but under the defense of my knight. And then as soon as I do that, the rook defends the bishop. So it was a good move actually. And it's going to go here. Yep, still this one is defended twice. Pretty beautiful. Whoa, I already wanted to push it. Just not thinking about this. Just not think about that. Now he just basically lost a rook, right? I mean, it's so restrictive now. So restrictive. Shall I give away my rook? I go here, he takes, I take, he takes my rook. Oh no, I have nothing. Yeah. I can't take his bishop. That would be an exchange, and I don't have time to think about it anyway. I could put his king there, and then I have check, he goes there, I could exchange that. Yeah, see, that doesn't help me one bit, of course. Now this rook goes to the 7th row. At least it threatens something, I think. Not really, I'm just running out of time. Let's kick this. Let's kick this guy here. I cannot kick it. Oh boy, that's horrible. Yeah. Oh boy, what to do? Kick the rook anyway. Rook is worth a lot. 21 seconds left. I think he's going to go here, and then this is still attacked. I'll have to attack it again. I can only attack it with my king then. So if he goes here, I must play king h2. Otherwise I just take his rook. Yeah, leave that there. Oh, I could have taken this pawn. Oh well. Oh well. Yeah, I want to double my rook, but I can't because bishop is looking at it. Hey, but now I can double it. Probably not wait for that, right? Let's just do it. Now, I wanted to move this pawn up first one because I don't know where the knight is going, but I just don't have time. I have to defend this pawn. Oh, I already do now, so now I can move it up too. And then we have a problem. He's gonna take here? No, he's not. If he does, I win the bishop. No, let's defend this pawn anyway. I was planning something. Oh yeah, the king goes to g3 and then my knight goes back. And then I threaten to take here and win something. Oh, like that. Oh yeah, that's nasty. I have to defend it. It was pinned, so I couldn't move it up. Now I can move it up. Let's defend my pawn here. Oh, I give away that pawn. Oh, that's not good. That's not good. But okay, at least I can take this pawn here. If he does that. I think I'm going to do that anyway. Can't defend that one. Could I? I don't think I could. I need to get rid of this bishop. So my knight has to come into play again. Let's go to this square as I had planned. Yep. Still attacking the bishop. So get rid of the bishop. Gobble up pawns. And now promote. What is that? Another pawn. And I can go forward, I guess, because this is my free pawn. Ah, you're gonna be kidding me. Of course, I realized when I moved here, I realized somehow that it was, you know, a bit scary. But I was still in the I'm down on time mode. So I thought, well, it feels scary for a tenth of a second, but I move anyway because there's no way he's going to give me mate. But he had a mate. He had a bloody mate. Unbelievable. Unbelievable. That was bad luck. I should have thought a little bit longer. Yeah, I should have gone here or something, or even down even there. Totally one position. Right, okay. So they keep kicking you out. Huh? Keep kicking you out. Okay, what shall I ask ChatGPT? Oh, we didn't know that. We didn't know that. Produce meat. So that's real meat. Yeah, I don't know what to do. I'm gonna stop the stream. I'll be back tomorrow. Good night.